Hey guys, all right, I'm excited. Last day on the syllabus. I know we said we were going to talk about trading today, but as this course has been progressing, I've had a lot of students we talked to after class and just met around campus that said they just kept asking questions about development. Given that we're at tech, I mean, it makes sense. I get it. A lot of people hear code and everyone's like, I want to code, I want to develop, and that's really cool. And it's a lot of the work I do, and I thought, okay, you know what? I'm getting literally no questions about the finance side of everything, and only questions about the trading, about the development side of everything. And so went ahead and said, okay, let's do a little bit of rebalancing here. So as much as I really would love to just talk about trading, like all day, this is a recent one I executed in. It's just the most fun thing ever. I love trading. It's awesome. We were going to talk about some Forex specifics this week, but I realized we covered probably most of it in week 3. And also in week 2, you got that resource for that trading class that has basically all the strategies that that at least that we use to trade and that I use to trade. And then also in week 2, there was a lot of really in-depth development stuff for the more theoretical side of it and the mathematical basis for everything we're doing. Those are all really good resources, and I would really recommend if you want to really go into this field as a career or do anything serious in it, that you do go through all those materials from week 2, because they make a really big difference. That said, I am not going to go over any specifics in the Forex trading or any specifics in hardcore futures trading, because in general, you really shouldn't be starting out in futures trading anyway. And all I could really talk about all day is like how to set up brokers and like where the people are. And most of the futures, I don't know, a lot of them are just not US based. A lot of them are CFDs. A lot of them you can't be a US citizen. It's just kind of a nightmare right now with the whole getting into leveraged futures products. Notwithstanding, I understand most people here are just for like normal crypto investing. So like obviously there are the big players in the crypto exchanges that are just the normal crypto exchanges. And so we'll wrap that in at the end today when we cover how to really hold custody of your own assets on the blockchain like we did kind of early on in this class. That said, I'm going to start everything off with development. Over here, on the left is Ethereum. I'm going to kind of assume everyone's pretty familiar with Ethereum, at least heard of Ethereum. Really smart guy, Vitalik, one day, 2012-ish, said, hey, wouldn't it be cool if we could program Bitcoin to make it do cool money things? Smart contract, kind of a term we're all at least moderately familiar with. This idea of programming it to do specific things is a pretty well understood, at least, it's kind of an out there thing. Well, the cool thing about the whole idea of smart contracts is nowadays they're actually pretty standardized. So Ethermint is a pretty standardized implementation of just single core smart contracts executed on the Cosmos chain. And what you'll find in practice is they've rebranded Ethos, stuff like that. But what you'll find in practice is basically most platforms will let you execute smart contracts, execute arbitrary code, arbitrary logic on their blockchains, just running standardized code, and they all have different syntaxes, different languages. Ethereum is kind of the most popular one. It's also the one that most people start with when they start developing. So a really good resource to learn how to code Ethereum smart contracts is called Crypto Zombies. That's kind of what their logo looks like. They're great. They're really cool. Basically, if you have an understanding of Java, and then you go in and you do Crypto Zombies, you'll have a pretty solid base understanding of how to write Ethereum smart contracts. And that's really the best place to start because Ethereum's been around the longest. It's what, at least number-wise, the vast bulk of development is on. And it's kind of the base benchmark of being able to do anything as a crypto developer. Um, in terms of getting the coding background for any of what we're going to talk about with Crypto Zombies or with any of these platforms, that's kind of out of the scope of what we're doing here. So you're going to have to learn how to code, one way or another, whatever the languages are. You'll find that a lot of the smart contract languages are based on like mostly Java. It's mostly Java. There are some newer ones that are kind of weird, and they're like, we want you to write everything in Haskell, and it's going to be so cool that everyone's going to love it, and it's going to be impossible to use. Uh, but you'll find that most smart contract platforms let you directly port code that's written in Solidity, which is again just basically Java with a couple of cool, there's some cool stuff with it. And the big idea behind all that is that you can put the code on the blockchain and have all the validators run it, and it won't break everything, and you'll pay money for it to compensate them for executing it. Some more details behind it. It's not like a huge deal. But yeah, so you'll find that most of the development you do in Ethereum smart contracts will transfer over to everything else. And so that's really the best place to start if you're just starting to learn about getting into development. Moving away from smart contracts, you'll start to get more into protocol level development. And this is where you start to see more C code. That's kind of and sometimes a lot of it's in Go. So this is Cosmos. What you'll find, for instance, Crypto.com, before they had their Zero token, they had an original Ethereum ERC20 token, and then over time they said, we don't want to be a security. There's a lot of things that went on that made them kind of do what they did. And then they said, okay, and basically what a lot of tokens now is very common. Like I'm familiar with a couple of, at least I'm familiar with 3 guys that went out and started their own projects just based off of all you do is you just fork the Cosmos chain, and then you just run your own blockchain. And it's really simple. It's just running like we talked about last week. You just run a PBFT consensus model based on proof of stake usually, and bam, you have your own blockchain and you have your own coins. And that's the big difference between smart contract development and then actual blockchain development, is the smart contracts will run on an existing blockchain versus making your own blockchain with blockchain development. What you'll find, there are a lot of really cool innovations in the smart contract space. The big trade-off between the two is usually when you go and you make your own blockchain, you'll have a lot more throughput, which means you can have a lot faster transaction times going through, and also a lot lower fees. That's one of the big reasons most people will fork their own blockchain, is because they have some utility they want from it, and they don't want to be, for instance, if you develop on Ethereum, you're basically bogged down by the Ethereum transaction fees. You're bogged down by the network speed, which is nice, but comparatively. Um, there are some, like Avalanche has a really, really cool smart contract development, uh, some really cool innovations they've done where basically instead of just being one single core going line by line through the contract, which is how it's usually done, with Avalanche, you can actually execute like through multi-cores, so you can have kind of parallel execution. Another one that does that is Zilliqa. They do it through sharding, so it's a little bit different than the way Avalanche does it. Avalanche does it, they sort of do it through sharding, and then they also have the validators run like 3 states of their own chain. It's pretty interesting. It's a little deep, but the basic general idea is that there are platforms you can go down, where you can have faster smart contract execution. And then in general, if you're going to do your own thing, you'll usually do that on your own blockchain so that you're not limited by the throughput of the Avalanche network. You're not relying on the Avalanche network. However, if you go and you run your own blockchain, very clearly you're going to have a much higher kind of barrier to entry. So it's going to take a lot more investment. If you go and just launch a smart contract app on whatever chain, usually you're going to have wallets that already support it. You're going to have systems that are already built around whatever that chain is. And you can pretty easily go, and we'll look at wallets in a second, but you can pretty easily interact with smart contracts. Whereas when you launch your own blockchain, usually you have to rebuild everything, not necessarily from scratch. Like you can just fork the Cosmos SDK and kind of change a couple things, and then bam, it's like your own blockchain. Similarly, you can fork basic wallets and just kind of change a couple things like the branding and all, and then say, okay, cool, this is our new wallet. And there are plenty of public repositories out there, like only for that, and they're all great. But it's just a little bit more work usually, and you'll find that this is the route more kind of in-depth projects go, more developed projects go, and a lot of them just start out as tokens. For most of the really, really highly pumped offerings that came out kind of towards the tail end of 2017, they all basically started out as ERC20 tokens, and then over time, most of the larger ones went on and forked Cosmos or something similar and made their own blockchain. And that's kind of a familiar path we've seen a lot of. And so it begs the question, okay, well, do I want to develop with smart contracts? I want to develop with protocols? And the answer is fairly split. Here's, for instance, the only 2 job postings for Evmos, which was that general purpose Ethereum virtual machine, that general purpose blockchain virtual machine that Cosmos runs. And you'll see that one of them is on soft smart contracts and the other one's on core protocol. And there's kind of this split between what do we want to work on, because it's a lot of different work in each one. Usually you'll find with kind of more startup type enterprises where they're building out some application, it'll be more smart contract work. And then with the more established ones, you'll have like blockchain, like the entire ecosystem itself will be hiring, and those will be more core developers. What you'll find in more traditional industry companies is mostly leaned towards smart contracts, and then the other kind of big half of it is just security implementation and setting up wallets and stuff, which we'll talk about in a minute. So it's kind of a split between the two. In general, though, you really can't go wrong learning the core fundamentals of how everything works, and then learning how to do the smart contracts, which is pretty trivial if you know Java. And then learning how to do the core protocol. A lot of times it's just small little changes here and there. And you really can't go wrong with that. I've never ever seen a blockchain engineering job with a starting salary less than 6 figures. So if you want to go down that path, it's like a pretty solid way to go. With that said, when you get into, for instance, smart contract development or even core protocol development, this here on the left is the first kind of beta implementation that we wrote at Block Transfer in Solidity on Ethereum. And as you can see, it's kind of lengthy. The thing is, when you deploy these contracts, you'll just deploy them to the blockchain, and it's just one big file. So if you have a smart contract, like all of the code has to be in one smart contract, give or take. There's some things you can weave around, but generally, you have all the code in one contract. And since everything's generally open source when you work on blockchain projects or crypto projects, what you'll find is that you're usually working with other developers. A lot of times, there's a lot of really great open source collaboration. And so something that's really important when you get into actually writing these contracts is having clean code that other people can read and very easily understand. I've gone through dozens and dozens of crypto projects that had just the most horrific smart contract code on the planet. It was absolutely disgusting. And some of them are from companies that are literally market capped billions and billions of dollars, and their smart contracts are just object-oriented messes. It's just disgusting, and it's like seven inheritances. It's gross. So I really recommend if when you kind of go down the smart contract development route, read clean code. It'll make everybody so much happier. It'll also make it a lot easier to showcase your code if you're trying to apply to work at projects or something like that. One of the best ways to do that is to just work on open source stuff and make contributions or maybe make your own projects. A really great place to do that if you want to start building up a track record of work and also get some money on the side is a place called Gitcoin. They're really cool. People will go on there and they'll post grants or bounties for smart contract work, blockchain work, stuff like that. So Gitcoin's a really cool place to start there and practice. When it comes to executing smart contracts, this is again a beta implementation of the block transfer contract we had just on a test net. And what you'll see is very, very simple here. You have just this address here, this hash here at the top, and then kind of you have a fee you'll use to execute everything. So that's just the network fee on Ethereum. That'd be like the gas. And then you'll have here your contract address. So that address is effectively, here's the contract address. This address lives on the blockchain just like any other public address would live on the blockchain. So you can go into a block explorer and you can look up someone's address, you can look up someone's public key, and you can also find the address for every contract that's out there. And the cool thing is that as soon as you publish a contract, and depending on the network, there's different ways, there's different kind of paths to do it. But usually it's just a simple transaction. You just put in the code, you'll compile it in a very standard compiler. You can look up, ETH compiler, and it's Solidity compiler. It's like the first result. It's not a big deal. And so what you do is you compile the code, and you'll get this bytecode here. And then you just put that bytecode in some transaction. You put it up on the chain, and then bam, you have a contract that's up on the chain, and that bytecode is public. So a cool thing you can do with that is you can reverse reconstruct the contract from the bytecode, and then you can also just upload the bytecode in a repository or something, and then everybody can very clearly see that yes, this bytecode is the same as if we compile this contract that's public. And by properties of SHA and collisions and what we've seen earlier, those are effectively going to guarantee that what you say is the code is actually the code because it compiles to the code. And that's really cool because it lets you put out projects and then show everybody, hey, this is what my project does. And that was basically the genesis for most of like the market makers that you'll see, most of what is termed as DeFi, which is what a lot of newer work in the industry is this idea of having, okay, we have this contract and I'm going to send in Ether and I'm going to get out some arbitrary token. That basically all of those, at least the vast bulk of them, are literally just smart contracts sitting on a network. And you can go and publicly look up the address of those contracts and very easily see, for instance, that they're making thousands and thousands of trades a day. based off no central counterparty, just using a contract that has a set of rules. Now, with that said, I think we're all kind of familiar with contracts at this point, and we all have a fairly decent understanding of blockchain development. One big caveat with developing your own blockchain or trying to mess with anything that's already out there is that you can get into some pretty big challenges if you have like any kind of security vulnerabilities whatsoever. And the same holds true with smart contracts, sometimes even more so. We all kind of familiar with the DAO. We've heard of the DAO. Um, Crazy, a lot of people have it. You'd be surprised. Long, long, long time ago, basically someone said, "Hey, I want to have this smart contract. We can all put our money in it, and then it'll put money into venture companies, and we can invest through it." And at the time, they took in a couple million bucks, a couple hundred grand, and what happened is the smart contract was just some code on the blockchain, and the idea was it would send it to the projects, and they would get a return on it, and everyone would make a bunch of money. But in reality, there was this one little bug in the code, and whoopsie, you can drain the entire contract because the code's public. And if you call this one specific function, whoopsie, you get all the money in the contract. So in the matter of like less than a quarter, the equivalent of 56 billion in Ethereum was drained from that smart contract today, that much today. And that was kind of that was what made Ethereum and Ethereum Classic, the fork, the split in the network. It was kind of this whole big thing. And what you'll find is most of the time when you hear in blockbuster news about blockchain hacks, it's usually like a smart contract hack or some kind of wallet security thing, which we'll talk about in just a sec. And so really, really very important if you do any development on smart contracts, would really recommend you read Fundamentals of Smart Contract Security. I'd say it's basically required to do any production level work. It's a really good book that has a lot of really great historical examples of what flaws existed, and they still exist if you code poorly, and then how to fix them and how to get over them. So yeah, like that's really important. You can hire firms to audit your smart contracts, and we've looked at doing that before. And effectively, they'll charge you like mid five figures to six figures to basically go and look through the 15 or 20 common errors that are in this book. So yeah, I would recommend that instead, at least before you go and hire people. It's pretty common to hire people to audit it though, just because hacks suck, and they're really big problems if you try to run any kind of company. And then if you're creating your own blockchain, obviously there's even more important that you really have some smart people look at it. And you really do want to kind of get your own stuff audited because making your own chain itself really just is not, it's like if you have a problem in the protocol itself, and that protocol is across like 400 peers, and like you can't really do anything about it. It's basically, I mean, there are projects that very, very quickly lost 90% of their value because, whoopsie, something was wrong with our code. In one project in particular, the entire blockchain network went down for 8 hours one day, which is awful. Like, that's not the point. That's terrible, because they couldn't reach consensus. And subsequently, the value of the token just plummeted. And so it's really important that when you do protocols, you spend a lot more time on that security. And even if you're just doing like an MVP kind of thing on a smart contract, you really do want to run through just those basic checks of a lot of it's just recursive calls, and there are things that you wouldn't really think of initially, but it's like, wow, okay, this is very clearly a problem. And they're usually like 2 or 3 line solutions to them, just real short snippets of code that make a world of difference. And there's also some cool examples in the past of like, there's a lot of really cool smart contract hacks that are in that book. So it really, you should basically read that if you're doing any production level work.
To be fair, if your smart contract gets hacked, you're just out of luck. If you have a problem on your protocol, you can, since you're probably in charge of it, you can probably hard fork it and do different things to get it back to consensus instead of just everything being broken and not being able to do anything about a smart contract.
Yeah, it's a good because when you upload the smart contract, it's basically there until it gets killed off, or a lot of times it can be there forever. So yeah, you could fork your own protocol and make fixes to the protocol over time, especially if you control the influence over the network. Versus with smart contracts, it's just out there. If it's production level stuff, like when we implemented the beta version of the block transfer stuff, it's like you put the contract out there, and then if you want to run any software on it, you want to run like any applications on it in the real world, it's always referring to that one contract. So you really can't fix the problem without deleting everything and destroying everything. But with your protocol, yeah, you can like hard fork, and that's what Ethereum did after the DAO. And there are some other examples where that's happened, but not as much of an extent. But none with smart contracts. So there was that time like someone lost like 14 million in a smart contract, and it's like, oh, sorry. But there was also that time someone paid like $8 million in gas, and the mining pool caught it, and they were kind of cool about it, and they were like, hey, we'll give this back to you. Um, that's a really good point. Yeah.
There's an interesting intersection there about like the legality of receiving that gas
Yeah.
because a court might say that this is clearly mistaken. Clearly, you don't actually have the right to these funds, and a court might order that the company repay it. And so, depending on how publicly that mining company is,
Oh.
they might
Well, if it's a
they might
pool,
yeah, but
who do you go after? That's a good
if they
point,
haven't
though.
been paid out yet.
Yeah.
Um, but there's an interesting intersection
That
there
is
with
cool.
legality. But
Yeah, you could maybe sue. That's yeah. Well, because they never found the DAO hacker because everything was pseudonymous, and
mm-hmm.
so it's just an address on the network who took all the money.
Yeah,
So there's no one to sue. But yeah, you could sue. Yeah, 100%. So there's some kind of real world ties into it. Um, Speaking of hacks and stuff, now we're gonna talk about wallets, and this is kind of gonna wrap everything up and give us the avenue to hold all of our assets. Kind of the big differentiator, the big deal with wallets is you have a hot wallets and you have cold wallets, and these are just kind of general terms. What you'll see with hot wallets, these are things like MetaMask. So you download MetaMask on your browser, and you can use it to run like arbitrary Ethereum contracts, arbitrary Ethereum tokens. You can trade Ethereum on it. You can send Ethereum on it. It's just like any standard crypto wallet. You can send money. You can execute transactions. You can execute functions in smart contracts. And the thing with these is they're always connected to the internet. So it's a Chrome extension. So it's always kind of connected to the internet. There's a cool case study with with one really big crypto founder, and basically, he was transferring some tokens on MetaMask, and somehow a group of hackers got into his computer and they edited the Chrome software, the back end of it, and made it. He was sending like $50 to some address to do some trivial thing, and and they hacked it so it looked like he was sending it on the UI to his own address. But in reality, in the back end on MetaMask, he was signing a transaction that sent, I think it was like a third of the total token supply of the crypto project to the hackers. And so very clearly that caused just a total crash in the price because the dude had a third of his funds in a hot wallet. And so just in general, what these terms mean is you'll have a hot wallet. That's like if you think of Coinbase, for example, they'll have, I think, 98% of their funds in cold storage. Cold storage just meaning you have your backup seed, you have your monomic, you go, you put it in a safe, and it's not connected to the internet. It's just in a vault somewhere. Versus the hot wallet is like, okay, we have this application wallet. It's got money in it. It's got seeds in it. We can go up to the computer right now. We can press the buttons. It'll send the money. This would be kind of more like if you have a phone, and in your phone you can just open up the app and send the money. That's kind of the differentiator. And so Mt. Gox was set up like that. It was a big Bitcoin exchange back when everything was starting up, and they had their cold storage offline. I don't know the percentages. Maybe 2/3 of it was in cold storage. I don't know off the top of my head. And then they had the rest of their money in a hot wallet. And what happened with Mt. Gox is somebody was able to get into the system, get into the server, get into the computers that were running the wallet software, and they would just drain like 100 grand. What was it? It was probably like 10 grand a day. They just kept draining 10 grand a day for like a year and a half or something, and no one ever realized. Oh, hey guys, we're sending all because it's a Bitcoin exchange, and they had thousands of transactions, stuff like that. So those hot wallets are the ones that you want to be really aware of and careful with, and those are going to be the ones that you run on computers, you run on instances. If you run them in servers in an enterprise setting, those are going to be generally the target of leaks, and that's where you're generally going to find problems with your security models. Another thing that's really important when you have your cold wallets that are in storage, and we'll look at just a minute at how to maintain those cold wallets. But when you have them in storage, you really want to make sure you have proper security around them and also proper business continuity. So this past summer, we went through the CreateX Accelerator. There was another crypto project in the program, and their idea was they would be like a third-party multi-sig. We're kind of familiar with multi-sig, like Alice and Bob have to sign the transaction to send money from the wallet, whatever. Kind of a general thing. It's in most blockchains. You can do it pretty trivially with just the cryptography itself, with secret reconstruction, like we talked about with Shamir. So their whole business was like, hey, you pay us a little bit of money, or I think they're doing it for free right now, whatever. And we'll be a third-party multi-sig, so we can do a one of three multi-sig, or one of two multi-sig. And if you ever lose your seed phrase, don't worry. Or if you ever lose your crypto secret, don't worry. We'll send you all your money. Just contact us and answer your super secret security questions, stuff like that. And I asked them what their business continuity plan was. If like a pretty common question you'll get from VCs is, if everybody in the company is on a plane and the plane goes down, what happens? And that particular instance is something that in this example, they didn't think about it at all. And a lot of companies don't think about that, especially with crypto companies. They just place all the trust in a couple of people at the top of the company always doing what they're supposed to do.
It's kind of
And
ironic.
yeah, it is ironic. It's completely like backwards from what you would expect with this whole idea of decentralizing. And that's why most crypto exchanges are awful, because there was this one exchange in Canada, and I think they had 40 million in assets off the top of my head. And one day the founder just vanished off the face of the earth, and he was the only one who had the cold wallet secret seed. And he's like, I died, everybody, even though like theoretically I think they think he moved to Italy or something like that, and just took all of the crypto because he's the only one with the cold wallet seed phrase. And so what you'll find in enterprise settings is you really want to remove that central point of failure by having proper cold wallet key management systems. So yeah, that's a really, really big thing. And the way you execute that is pretty trivial. You'll just have cryptographic secrets. So for here on the left, we have just mnemonic seed phrases. These are kind of the standard way to store seed phrases. A couple of cool tools on the market will let you do that. You just punch it into metal, and that's really cool in case your house burns down. Stainless steel won't burn up to like 1300 Fahrenheit, and it won't obviously get affected by a flood or anything like that. So you can kind of hide it around, wherever you want to hide it around. And that's a cool way to manage your secrets. And then the idea being that you would have basically the executives of the company. What we do is a 5 of 8 multi-sig, and you can manage this really securely using hardware wallets. So the cool thing on the right here, we see just kind of the two leading hardware wallet brands. The cool thing with hard wallets is they do all the signing, all the signatures, all the key management offline. So you'll have this little device, you just plug it in the computer. The computer sends over whatever it is you want to sign, and they have wallet softwares. They have integrations for all the major, even all the like they have integrations for thousands of currencies. And then you can sign it locally. You can verify all the information is correct, and you know that you're not getting the wallet address isn't changing because it's verified locally. They have a lot of really cool security that does that, and also most of these projects have open source code. So for Ledger and Trezor, like their whole protocol, everything they run locally on the device is open source, and all the hardware is fairly trivial. It's pretty it's like not really super crazy.
I think the Trezor is completely open source.
Yeah,
The Ledger uses a proprietary
just a
secret
little.
algorithm
Yeah,
to,
I like Trezor more, but with Ledger, there's some things you can only do on them because,
yeah, Ledger has more assets you can
yeah,
rely on.
yeah. Um, so you can kind of see everything that's going on there, and the point is that your keys aren't on your computer anymore. You don't have like some file on your computer that has whatever your backup phrase is, and you don't have some wallet on your computer that's storing your backup phrase or some derivation of your secret that's being used for your wallets. And instead, it's just on this little thumb drive, this little device that is only built to sign transactions. And what that effectively does is makes it impossible to steal the secret key from it um, using a remote environment. So if I'm here, someone in India or wherever, right, someone across the globe can't just hack into my computer and steal all my money because it's on this device that's in my phone, in my hand. You passphrase protect it. There's some cool hardware side channel attacks you can do if you get the physical device. I could talk about those a lot. It's actually really interesting. One thing you can do is you can have a passphrase on top of your crypto secret, and if you don't use a passphrase, which is like there's like trade-offs, because you have to remember the passphrase. What we do is we'll have like those capsules for the seed phrase, and then we'll use tiles like these for the passphrase, and we usually have pretty implicated passphrases. The reason why is because with the Trezor at least, there's a power side channel attack you can do where if it's not passphrase protected and you get the physical device, you can bypass the pin and get the secret key, the secret phrase from the physical device using a power side channel attack that's not preventable. At least that's what they say, and that's what they've been saying for a couple of years, um, just because of the chips that they use. So, and the way the memory is managed. Notwithstanding, these guys usually have really good memory management. They'll wipe the chips after 10 chip, whatever. And the important thing with all of this is that with these hardware wallets, you can throw it in a river, you can break it, whatever, it doesn't matter, because your money and your assets and whatever you're holding on the blockchain is tied to that cryptographic secret. And so it doesn't matter. You can just replace it, you can load it up off a new crypto secret. In an enterprise solution, when you start to really implement this on a company scale, it just comes down to distributing a couple of these devices, a couple of seed storage, and then just properly delegating it so that a couple of rogue employees can't mess up the entire business. That said, that's basically the bulk of it. That was kind of everything I wanted to go through, and everything I think that we've gone through in this class to go from effectively nothing to going and having all the tools to develop enterprise grade solutions, and also really understand how to invest and you'll send your assets right to the public keys associated with these wallets or whatever your crypto secrets are. And even if you're just starting out, like you can use MetaMask wallets, you can use Jacks and stuff like that. You won't, die because of it. It's not like the worst thing ever, just to get a taste of everything. And that's kind of the big key with most of the development. And then if you go and really just practice and execute, whether it's practicing trading or practicing doing development and contributing to projects and building your own projects. Building your own projects, I'd say, is probably the best way to do it. When I came into college, I hated coding, absolutely despised it. I was like, oh my God, this is the worst thing ever. I never want to code. I'm just going to hire a bunch of people with all my stock money to do coding because I never want to do it. But really quickly, I realized that it's very expensive to hire talent in the blockchain space. And there are very, very few people that really understand this stuff at a deep level. And so you get a lot of value learning this. Just if you want to do it in the market, it's a really solid path to go down. And if you want to do any kind of development or lead any kind of project or deep investing in this space, kind of an investing company, you really want to kind of understand what's going on. And I think that's kind of what we've done here. And I'm really excited to have shared it with you. And I wish you the best of luck with investing and development and kind of everything you do afterwards. Yeah.